All right, welcome to the deep dive. You know we love getting your requests, and you've sent us a ton of stuff about whirling machines. It seems like you're all pretty eager to get a handle on this tech and how it can be useful.
Definitely a lot of buzz about whirling lately.
Totally. So we've been digging deep, and in this deep dive, we're going straight to the heart of it. What exactly are whirling machines? How do they manage to make those insanely precise external threads? And what are the real advantages they've got over those old school methods?
Yeah, the precision is a big deal.
Right. So our aim today is to break down those core concepts, really highlight what makes these machines so powerful and why they represent a big leap forward in how we manufacture parts with threads.
A real game changer in a lot of ways.
So to kick things off, we'd like to go right to the source. What is a whirling machine in a nutshell?
Okay, well, a whirling machine is a specialized piece of equipment. It's designed to create precise external threads, and it does this by using carbide or other types of advanced cutting tools. These tools are mounted on a high-speed, rotating cutter ring.
So it's not like your typical lathe.
Right, not exactly. Think of it almost like a super optimized milling process specifically for threads.
Milling, huh?
Yeah, instead of a single cutting tool, you've got multiple cutting edges working together.
Interesting. So how does this actually work? How do you get from this super fast spinning to a perfect thread?
Okay, so picture this. You've got the whirling head, and it's got that cutter ring I mentioned, loaded with multiple specialized cutting inserts.
And these inserts are shaped to the exact thread profile you need, right?
Exactly. Each insert is perfectly formed to cut that specific thread form. Now, this ring is spinning really fast, and at the same time, the workpiece, the part you're threading, is held and rotated, but much more slowly.
So you've got this fast spinning and slow rotation happening at the same time.
Right, and it's this synchronized movement that's key. The entire whirling head also moves linearly along what's called the z-axis.
Okay, so this linear movement controls the pitch of the thread, like how far apart the threads are.
Precisely. And here's something really cool. Just by changing the direction of that z-axis movement, you can switch between cutting right-hand and left-hand threads.
Oh, wow, so it's that versatile.
Oh yeah, and there's more. There's another axis, the a-axis, and it allows the whirling head to tilt.
Tilt, what's that for?
It tilts to match what's called the helix angle of the thread. Imagine the stripes on a candy cane.
Ah, I get it. The angle of the stripe as it wraps around.
Exactly. For external threads, these machines can often tilt plus or minus 40 degrees. It's a pretty wide range, so you can create a lot of different thread types. Then there's the x-axis, which controls how far the cutter ring moves toward the workpiece, setting the depth of the cut.
So that's how you get the right minor diameter for the thread.
Exactly.
Wow, so there's a lot going on. High-speed spinning, slow rotation, linear movement, tilting, depth adjustment. It sounds incredibly intricate.
Yeah, it's quite a bit of coordinated movement, but the beauty of it is that the thread is often machined in a single pass. The process also creates a very distinct type of chip. It's often described as comma-shaped.
Oh, interesting.
And even though it's an interrupted cut because of those multiple inserts, the result is a really precise thread with a great surface finish. It's also impressive because it can create a high-quality thread even if the surface of the workpiece isn't perfectly smooth.
So you don't need a perfectly even starting point.
Not necessarily. It can handle some irregularities, which is a big advantage.
So we talked about it being fast and precise, but I remember you mentioned it can also handle some pretty tough materials.
Oh, absolutely. Whirling machines can cut materials that are very hard, up to about 65 on the Rockwell C hardness scale. They can even handle brittle materials that would typically crack or chip with traditional threading methods.
65 HRC, that's pretty impressive. What about internal versus external threads?
Good question. While whirling can technically create both internal and external threads, it's much more common for external threading.
I guess that makes sense given the helix angle adjustment and everything.
Right, it's a lot easier to control the angle when you're working on the outside of a part.
Okay, that makes sense. So we've got a pretty good picture of how these whirling machines work.
Yeah.
High-speed, multi-axis, single-pass thread milling. But the big question on everyone's mind, and mine too, is why bother with this instead of just sticking with a traditional lathe? The way we've always done threading. What are the big advantages here?
Right. Well, if you've ever worked with traditional lathe threading, you know it can be a bit of a headache.
It can definitely be time-consuming.
Exactly. You often need multiple passes to get the thread right. The tools can wear out quickly, especially on those tough materials. Then there's the coolant, keeping everything lubricated and flushing away those chips.
Yeah, it can be a messy process.
It can be. Whirling addresses a lot of these issues. The benefits are really significant.
So let's talk about those benefits. What are the main reasons why someone might choose whirling over traditional threading?
Well, the first one is speed. Whirling machines can significantly reduce production time, sometimes by up to 70%.
70%, wow. So we're talking about a huge increase in throughput.
Exactly. And this is largely due to that single pass capability. It eliminates a lot of the steps and cuts down on the overall machining time.
So that translates to big gains in productivity.
Absolutely. Lower cost per part, faster turnaround times. It's a big deal, especially for high volume production.
Faster is always good, but what about quality? Can something that fast also be accurate?
It can. The surface finish you get with whirling is generally excellent, often comparable to grinding, with a roughness average of 0.8 micrometers or even better.
Hmm.
And because of the way the cutting is done, there are typically fewer of those tiny peaks and valleys you sometimes see with other threading methods.
Smoother threads.
Exactly, smoother threads. And that means you can often reduce or even eliminate the need for additional finishing work.
That's got to save a ton of time and money.
It does. Another advantage is that whirling often allows for what's called dry machining.
Dry machining, so no coolant.
Exactly. Because that rotating cutter ring does such a good job of getting rid of chips and heat, you don't always need coolant. So you eliminate the cost of the coolant, the mess of dealing with it, and you have a cleaner process overall.
So it's a more environmentally friendly process as well.
It is. And there are even savings on setup time. With traditional threading, you might need to carefully match roughing and finishing tools, but that's often not necessary with whirling.
So simpler setups, lower operating costs, and a cleaner work environment. Sounds like a win-win-win.
It really is.
You also mentioned earlier that whirling is better for handling those tricky materials.
Yes, it's a real game changer when you're dealing with those tougher jobs. Hardened steels, titanium alloys, super alloys, stainless steels. These materials can be a nightmare for traditional threading tools, but whirling handles them effectively.
So it opens up a whole new world of possibilities in terms of the materials you can work with.
Exactly. If you're in an industry that relies on these high-strength materials, whirling can be a lifesaver.
What about long, deep threads or really thin parts? How does whirling stack up in those scenarios?
Whirling is really good for those applications as well. It's particularly well suited for deep thread profiles and parts that have a high length to diameter ratio.
Meaning those long, skinny parts.
Right. Because of the way the whirling head is designed, it offers better support and rigidity compared to a single point tool on a traditional lathe.
So that reduces vibration and chatter, which can be a real problem with those long, thin parts.
Exactly. It means you can confidently work with more complex geometries that might be problematic with other threading methods.
So better support, less vibration, and the ability to handle those trickier shapes. What about the accuracy of the thread itself? I know we talked about surface finish, but how does it measure up in terms of dimensional accuracy?
The accuracy is excellent. Whirling delivers high dimensional accuracy and produces a very precise thread profile.
So you get parts that fit and function reliably.
Right. The quality is very consistent, and the accuracy can often exceed what you can achieve with other threading methods.
So what about tool life? Does all that high-speed spinning mean the cutting tools wear out faster?
You might think so, but it's actually the opposite. Because the cutting load is distributed across multiple inserts on that cutter ring, it can actually extend tool life compared to single-point turning, where all the force is concentrated on one small area.
So less downtime for tool changes.
Right. Less downtime, more consistent performance. It's another one of those unexpected benefits.
So we talked a bit about the flexibility of whirling in terms of materials and part shapes, but you also mentioned that these can sometimes be integrated into existing equipment.
Yeah, that's a key point for a lot of manufacturers. There are whirling attachments available that you can mount onto existing CNC lathes.
Particularly Swiss-type machines, right?
Exactly. Those are known for their precision and multi-axis capabilities. This allows you to add whirling to your existing workflow without a huge investment in a completely new machine. But if you're doing high-volume production, you can also invest in a dedicated whirling machine, one that's specifically designed for this type of threading.
So you can scale the technology to fit your specific needs.
Right. There's a solution for both small shops and large manufacturers.
So when we talk about scale, someone might be thinking, well, this all sounds great for very specific niche applications, but can it really handle large-scale production?
That's a good question. It's easy to assume that something this precise is only for small, intricate parts. But the truth is, whirling machines can handle both ends of the spectrum.
Okay, so how does it work for both small-scale and high-volume production?
Well, for large-scale manufacturing, you have dedicated whirling machines that are engineered for speed, reliability, and often integrate seamlessly with automated systems. They are designed to churn out thousands, even millions of identical parts. This is ideal for industries like automotive or medical device manufacturing, where you need that high volume output.
So you're saying these dedicated machines are built for speed and volume.
Right. They maximize efficiency and throughput.
But what about smaller manufacturers who need more flexibility? Maybe they're doing smaller batches or a wider variety of parts.
That's where those whirling attachments for CNC Swiss type lathes really shine. It allows smaller shops to get the benefits of whirling without having to invest in a whole new machine.
So you can add that capability to your existing lathe.
Exactly. You maintain the versatility of your lathe while getting the precision and speed of whirling.
So there is a solution regardless of your production scale or needs.
Right. Whether you're making a few prototypes or running continuous production, whirling can fit into the workflow.
So we've talked a lot about the how, but let's talk about the what. What kind of parts are actually being made with these machines?
Whirling machines can make a surprisingly wide range of threaded parts. Of course, there are your standard screws and
The
bolts.
fasteners that hold everything together.
Exactly. But they can also create more complex parts like worm gears and shafts, which are crucial for things like power transmission and steering systems in
It's
cars.
essential for a lot of machinery.
They're also used to make lead screws, including those incredibly precise ball screws used in machine tools, robotics, and even aircraft. And you'll also find them making things like pump rotors with their helical twisting shapes.
So a lot of applications beyond just your basic fasteners. You also mentioned something that surprised me, medical parts.
Yes, the medical device industry is a big user of whirling technology. They use it to produce critical components like bone screws for fracture repair, spinal fixation screws, and even dental implants.
Wow, that's pretty amazing. So we're talking about parts that are literally implanted into the human body.
Exactly, and these parts often need to be made from materials like titanium or PEEK, which are very difficult to machine accurately with traditional methods. They need to be incredibly precise and biocompatible.
So the accuracy and ability to handle these tough materials are critical.
Absolutely, whirling really shines in these demanding applications.
So we have all these parts, from screws and gears to medical implants. Where do they all end up? What industries are relying on these whirling-made components?
No, the applications are really diverse. Obviously, you have general manufacturing where precise threads are needed for all sorts of assemblies, but it goes way beyond that. Aerospace, defense, automotive, the medical device industry, as we just discussed.
It's a pretty wide range.
You'll also find whirling-made components in the energy sector, things like power generation and oil and gas equipment. And even the machine tool industry itself uses whirling to create the precise motion control components that go into other machines.
It's really interesting how this technology, which seems so specialized, actually touches so many different aspects of our lives.
It's true. It really is a fundamental technology when you think about all the industries that rely on precise threads.
Well, it's been a fascinating deep dive. Whirling machines are definitely more than just a niche technology. So to wrap it up, it seems like we're talking about a highly efficient method for creating those precise external threads with some major advantages over traditional turning. We've talked about the speed, the surface finish, the cost effectiveness, and the ability to work with some really difficult materials.
Definitely a game changer.
And it's scalable with solutions for both small, high-precision jobs and for large-scale manufacturing. So it's not just for one type of industry or one type of application.
Right, it's a versatile technology.
So as we wrap up, I want to leave you with a thought to consider. As we see continued advancements in whirling technology, what new possibilities might emerge? What new applications might we see in the future? How will this impact the design and manufacture of the products we rely on every day? It's definitely a technology to keep an eye on. Thanks for joining us for this deep dive.
Thanks for having me. It was a great discussion.